Hello everyone. Today we are going to understand with example how aldol condensation works. Now in your textbook you might find three reactions pretty important and occurring one after the other. Aldol condensation, cross aldol condensation and Cannizzaro reaction. And all these reactions are extremely important from board point as well as your competitive exam point of view. So, what is the main factor of these reactions? The main factor of these reactions are alpha hydrogens. So, let's take an example of an aldehyde and a ketone to understand what is the alpha hydrogen. If we consider this particular compound, okay, so we all can see it is a propanol, okay. So, every aldehyde ends with an al. Okay, every ketone ends with an one. So we have propanol over here. If you notice, the terminal carboxyl group or the aldehydic group is the functional group. Any carbon that is attached to the functional group directly would be called as alpha carbon, and then the next carbons would be beta, etc. We are only focused with hydrogens of the alpha carbon. Okay, so the first carbon after any functional group, it could be any functional group, not just an aldehyde, would always be considered an alpha carbon, and its hydrogens are what we are interested in. Okay, let's take another example over here. Fine, we have a ketone. And as you can see, ketone carboxyl groups are not the terminal functional groups. They lie somewhere in the middle or within the compound, not at the end. So any carbon that is attached to a functional group is called as an alpha carbon. So you can see there are two carbons over here just next to the carbonyl carbon, and both of them would be called alpha carbons. So there are two types or two sections of alpha carbons over here, and each hydrogen attached to them becomes an alpha hydrogen. So what is aldol condensation? Aldol condensation firstly requires your compound to have an alpha hydrogen. That is what we study. And if you want to specifically study aldol condensation, you need to have two same aldehydes. So if I'm taking butanol, I need to take another butanol. Okay, if I'm taking ethanol, I need to take another ethanol. Okay, so when I react two same aldehydes together, I'm going to get aldol condensation. So let's take an example of ethanol over here. Okay, so ethanol's common structural formula would be CH3CHO. Okay, and we are taking two of them. While representing, please make sure this is a very important tip that whenever we represent aldols, okay, we want to solve aldol, try to expose one of your carbonyl carbons oxygen. Expose meaning what? Let's say you have recently made a tattoo and you want everybody to notice it, consider it, gorge at it. What do you want to do? When you want that tattoo to be of the importance in other people's eye, you are trying to expose it. Okay, you'll try to show it more so people can notice it. So how does this aldol work over here? You need to expose or show your carbonyl oxygen very, very precisely. If you show it in this way, your structure in this particular format, at least one of the aldehyde, I'm telling you the further steps of mechanism would be easy. Okay, so let's take our two ethanols over here. What does aldol actually suggest? That whenever ethanol comes in contact with another ethanol or one aldehyde comes in contact with another aldehyde, the carbonyl oxygen is partially negative. It is going to attract the alpha hydrogen of or the adjacent hydrogen of the next compound. So what happens? Hydrogen starts moving to the partially negative oxygen. Why? Because hydrogen is partially positive and the carbonyl oxygen is partially negative. So what will they form? They would be forming an OH group. So can you notice that when it forms OH group, this carbon and this carbon, they form a bond. So what is the logic? That hydrogen is attracted by the carbonyl oxygen and the two neighboring carbons are going to join each other using a single bond. This happens in the presence of base. You can have sodium hydroxide, potassium hydroxide, barium hydroxide, any base of your choice. In aldol and cross-aldol, the type of base or the base specific is not that important. You can use any base for that matter. Okay. Now see over here, OH is over here and we have a neighboring hydrogen. Together, this OH and H, they are going to be eliminated as water molecule. And what happens when water molecule gets eliminated? The carbons now they have open hands and H2O has left. So they join hands together to form a double bond. Okay, so how did we begin? We exposed our carbonyl oxygen and the partially positive hydrogen of the other compound got attracted to it. We got an alcoholic group or a hydroxy group over here. And the two neighboring carbons, they joined each other using a single bond. In the next step, condensation happened, meaning H and OH are pretty close by. So they are going to form a stable compound of water and get eliminated. What are we left with? Two carbons with their hands open. They join hands and they are going to form a double bond. Okay. Now see the beauty over here. Okay. We have an aldehyde group in the second structure. We have a hydroxy group or an alcoholic group in the second structure. So we call such a structure to be aldol, a compound having aldehyde as well as alcohol or hydroxy. Okay, so this second structure is called as the aldol structure. Water got eliminated. Now we have got the last structure. How to name this? Let's see the carbon. Carbon 1, 2, 3 and 4, meaning our base or parent carbon chain is 4. 4 meaning but. We can see that 2 and 3, between 2 and 3 there is a double bond. Give the least number of carbon to the double bond. So what is the least number? 2. 2 ene. Okay. And what is the actual functional group over here? The actual functional group is nothing but an aldehyde, and we represent an aldehyde using al. So butenal. Butane, basic or parent carbon chain. On the second carbon, you can find double bond. That's the way we notice it. Whenever you find that suppose two carbons are sharing double bond or triple bond, the least number of carbon which is given, that takes up the name. So we put it as ene, suggesting there is a double bond. And finally, al. So how do we go about it? We take an aldehyde, react it with the same aldehyde, we get aldol. After water elimination, we get an enal. Okay. This is how aldol process actually happens. But it's not just limited to your aldehydes. You can even consider ketones over here. Only issue being it won't be called as an aldol or aldol now. It would be more precisely called as a ketol because we have ketone group, right? So let's take an example of propanol and propanol. You can also call it propan-2-on, no problem. On meaning that it is having a carboxylic group representing ketone. How do we represent it? The same way. I told you, expose the tattoo. What is over here for exposure? Your carboxylic oxygen. Okay. So put your 1-methyl group down. Okay, because it's of no importance here. What is important? This oxygen, partially negative oxygen. Process is the same. Neighboring carbon, hydrogen gets attracted to this oxygen. Okay, so there's no much difference between both the reactions. So see, what is going to happen? Step number 1, partially negative oxygen, partially positive hydrogen, it gets attracted. When it gets attracted, you can take any base of your choice as a medium. You can find that hydroxy group gets created. What happens when hydroxy group gets created? The two neighboring carbons now can form a bond with each other. How is this happening actually? Oxygen attracts hydrogen and gives away one of its bonds to carbon. Now this bond which is given away to carbon can form easy linkage with the neighboring carbon. Or you can also remember it as once OH group forms, double bond breaks up, and that can be used to create a bond between carbon and carbon. Same old story, hydrogen neighboring to OH, together they will be eliminated as water. Now when they get eliminated as water, the two bonds are now open. The carbons join hands are going to form double bond over here. Same story, oxygen attracts hydrogen of the neighboring compound, water molecule gets eliminated, and alkene comes into action. How to name this? Let's try to understand. How many carbons? 1, 2, 3, 4, and 5. But I want you to notice something, that on the fourth carbon, we have a methyl group branching out. And whenever we are naming a base carbon atom or carbon chain, we need to first name the branch. So what is the branch? Branching is methyl. Branching is methyl. At what position is this branching? Carbon number 4. So we write it as 4-methyl. Okay. How many carbons are there? 5 carbons, meaning pent. Pentane, right? 5 carbon. Now the next thing that I told you, that if there is a double bond, give the lowest number of carbon the opportunity to take the name. So pent 3-ene. Problem being that we no longer have an aldehyde, we have an ketone. Ketone is on which number? Ketone is on second number. Aldehyde, the numbering is not important because the aldehyde group is already at the terminal position. But here we have the ketonic group not on the terminal position but on the second carbon. So 3-ene, 2-one. Some teachers are liberal enough with this respect that they won't even deduct your marks if you don't write 2-one. But it's a common IUPAC example of writing your numbers properly. Okay, so you are not at fault anywhere. So how did we name it? We first started with the one that is branched, methyl group. The number it is branched on is 4. So 4-methyl. Base carbon chain is of 5 atoms, so pent. On the third atom, we have got an alkene or a double bond group, so 3-ene. And on the second carbon, we have a 2-ketone group, that is 2-ketone or 2-one. So 4-methyl pent, 3-ene, 2-one. So what is the basic step? No matter which aldehydes or which ketones are being given, no matter how big the structure is, your logic is going to be the same. Expose the oxygen and attract the hydrogen to form hydroxy. Eliminate water, form the double bond. So if you have understood these two examples thoroughly, I want you to practice the other two examples mentioned over here. Try it out, and I hope that will make your aldol logic and aldol reactions pretty clear. Okay. Next video, I try to bring in cross-aldol reactions and how it differs from aldol. Okay. With this, we'll end the lecture. Signing off. Bye.